picking up for the last few. We have a tangent line to the graph of y equals g of x. So we're not given what the function is. And we're at the point 7, 7. The tangent line passes through the point 1, 6. And I need to find g of 7 and g prime of 7. Okay, so here's what this is. What I have is some random function. I don't know if it's increasing, decreasing, whatever. There's my function. Here's the point 7, 7 on the function. That's all I know so far. Okay. It also, the tangent line will pass through the point 1, 6. Okay, so 1, 6. I shouldn't have put that on there. There's 1, 6. So the tangent line to the graph will travel through this point. So the question is, there we go. All right, basic picture. Probably not the right one, but there you go. What is the value of g of 7? So this is just straight up algebra. I would like to know, if I shove in a 7 into the function, what will I get for an answer? What's the corresponding y-coordinate? Well, I was told that the point 7, 7 is on this graph. So g of 7 must be 7. That's algebra straight through. The next question I have says find g prime of 7. So that says, what is the slope of the tangent line? Well, I don't have an equation, so what do? I do know that there are 2 points on this graph. So the other one is one, boy howdy, I drew this wrong. All right, the other one is 1, 6. This is not drawn to scale. Okay, so if I know that these 2 points are on the tangent line, remember the only point that the tangent line shares with the actual curve is 7, 7. I can find the slope of the tangent line simply by using the slope formula from algebra. So this entire problem has nothing really to do with calculus, because there's no calculus stuff in it. It's just algebra. So what I have is y2 minus y1 over x2 minus x1. So y2 is 7, y1 is 6, x2 is 7, x1 is 1. So I end up with 7 minus 6 is 1, 7 minus 1 is 6. So I find out that the slope of that tangent line is 1/6. So the value of the derivative, or the slope of the tangent line is 1/7, 1/6, sorry, whereas the actual point has an x-coordinate corresponding y-coordinate of 7. Okay. This one, identify a function that has the given characteristics. So the first thing we know is it's a function. Okay. Then sketch the function. I know that the point 3, 15 is on this graph. The next thing I know is that the value of the derivative is 4 for all numbers. So the value of the derivative is constant for all numbers. It is unchanging. And the only function that we know of that has an unchanging derivative is a linear function. It's a line. Okay, so this just told you that your slope is 4 and you're given an xy coordinate. So can you tell me the equation of the line? I bet I can. So again, anytime that your derivative is constant, it's not a formula, it's a constant, you have a linear equation. So I have y equals mx plus b, which makes my y 15, my m is 4, my x is 3. So that makes my b 15 minus 12 is 3. Okay, so I know that the equation of my line is y equals, or f of x equals, slope of 4, y-intercept of 3. And then you're going to have to go in and plot this. So you know that it crosses at 3, and then it has a slope of 4. So I'm going to go 1, 2, 3, 4 over 1, and then I'm going to draw the line. Okay? And I think you just have to plot 2 points. So find 2 points. All right. So a couple more things as we wrap up this section. Find the equations of the 2 tangent lines to the graph of f that pass through the given point. So I've got 2 options here. I can either take this and do it the algebra way, which I think would be easier, or I can do it the calculus way. But since they've given me enough information here, I might as well do it the algebra way, because it's good for a refresher anyway. All right, so I'm going to look at this positive slope right here first. So what do I know? I know that my slope is positive, and it goes through the point 0.417. So what is my slope? So I need to find 2 points on this line. Well, if this is 15, then this is 16, and this is 17, and I move over 1. So my slope is 1, 2, over 1. So my slope is up 2 over 1. And now I've got the full equation, or I've got everything I need for the equation of the line. So I have a 17 equals 2 times 4 plus b. So 17 minus 8 is 9. So b is 9. So the one with the positive slope is going to have a slope of 2 and a y-intercept of 9. And even if you had looked over here at that, you would have been able to see it crosses at 9. I don't have the benefit of this because it goes off. So same thing. I need to find the slope. So what's the slope of the negative line? Well, if I go from here, I'm going to go down 2, right 1. So down 2 over 1 means a slope of negative 2. And again, the 0.417 is on that graph. So y equals mx plus b. I've got 17 equals negative 2 times 4 plus b. So I'm going to add 8 and get 25. So my negative 1 is going to be a negative 2x plus 25, and that should make sense. As you go up here, it's going to go off the thing. All right, so we've got, I'm just going to address this once, just because I'm supposed to. The alternative form of a derivative is a way for you to evaluate the derivative without taking a derivative first. It's a way to kind of sort of stay in algebra land for the most part. So the way that we're going to do this is this. The alternative form of the derivative is going to be the limit as x approaches c of f of x minus f of c over x minus c. Okay, so all it means is I'm going to write the function as it stands minus evaluate the function at the given value over x minus the given value. Okay, so here we go. We are given f of x equals x to the third plus 2x squared plus 4, and I'm told that my c equals negative 2. Okay, so what does this mean? First of all, the limit as x approaches c. What's my c value? It's a negative 2. Okay, I need to write the function as it stands. So my function as it stands is x to the third plus a 2x squared plus 4 minus. And now I need to evaluate my function at my given value of c. So what is negative 2 times negative 2 times negative 2? It is negative 8. Okay. What is negative 2 times negative 2? It's 4 times 2 is positive 8. Okay. And then I just have a plus 4 here. And then all of this is over x minus your given value. So x minus negative 2 is x plus 2. Okay. So now what do I have? I've got the limit as x approaches negative 2 of, so this gives me an x to the third plus a 2x squared plus 4. These 8's reduce, and this is a plus 4 minus 4. So this actually just reduces to this right here. So what do I have on the top? I can factor out an x squared, and that leaves me with an x plus 2 over an x plus 2. Okay, any number divided by itself is 1. And so now I'm going to take the limit as x approaches negative 2. So what is negative 2 times negative 2? It is 4. Now, I don't really see the point in cluttering up my brain with more stuff like that. So what happens if I say I don't want to use the alternative definition? Again, I'm not going to know what process you're using unless I'm staring at you through your dining room window, which we've already established is creepy. So I'm not going to do that. If you use the traditional method, take a derivative. So what's the derivative of x to the third? It is 3x squared. What's the derivative of 2x squared? It is 4x. What's the derivative of 4? It is 0. Okay, now evaluate that at negative 2. So 3 times, what is negative 2 times negative 2? That'll give me 4, plus 4 times negative 2. So I get 12 minus 8 is 4. You get the same answer. And so I don't know, if you know you're going to evaluate, then you could use this process, but sometimes you end up having to factor and it gets messy because you got to reduce and it's a huge nightmare. So other times I just think it's easier to stick with this way. Bottom line is I'm not going to know which way you do. All right. So couple things. When we want to take a derivative, 2 words need to be your best friend. I need my function to be smooth, which means no pointy parts. Look, there's a pointy part. Look, there's another pointy part. In math world, we call those cusps. Okay? So you cannot evaluate a derivative. The derivative will not exist on the pointy part. I can go around the pointy part all day long, but at the pointy part, I cannot take the derivative. It also needs to be continuous, and that should just be common sense, because if there's an asymptote, there's not a function. So if there's a hole or an asymptote, there's not going to be a derivative there. So as long as your function is smooth and continuous, you're good to go. So describe your x values at which your function is differentiable. That's a fancy way of saying, where can I safely take a derivative? So first of all, is it continuous? Yes, because I can draw this entire thing without ever lifting my pencil. But is it smooth? No, I cannot use, this is -2, -3, -4, this is 2, 3, 4. I cannot use -3 and +3. Okay? So I need to use my answer, or enter my answer using interval notation. So I can use every value over here. So I can go from -infinity all the way up to -3. But don't touch the -3. I can evaluate the derivative everywhere between here. So I can go from -3 to +3. But the soft brackets say don't touch. And then I can evaluate everything from 3 to +infinity. So this is a fancy way of saying I can take the derivative everywhere, just not at -3 or +3. So this is not interval notation, but this means the same thing as this. Okay? So this is differentiable for all real numbers, just not here because it's pointy, and just not here because it's pointy. All right, so that being said, here we go. We got 3 more problems. All right, we have describe where this thing is differentiable. So again, where are my off limits? Holy cow, it's the same answer. All right, this is -3. This is +3. So where can I use, I can use them everywhere, but at -3, I can go from -3 to +3, and I can go from 3 to infinity. So again, fancy way of saying everything but -3 and +3. All right, so this is the absolute value of x minus 5. What that looks like is a v that got shifted to the right 5 units. Okay, what's the value of the derivative to the left at x equals 5? So what I have is a negative line. So here's what you can think of this as. I can take this as a piecewise function, and I can say x minus 5 and then -x plus 5. Okay, so those are my 2 things. I write it the way it stands and then change the signs. So where is it positive? It's positive if x is greater than or equal to 5, and it's negative to the left of 5. So this is another way to write it. Okay, so what is the value of the derivative from the left? So what's your downward derivative? The value of the derivative is -1. Okay, what's the value of the derivative to the right? So what's this one? It's +1 because the derivative of this is 1. Is it differentiable right there? No, because it has a pointy part, so it is not differentiable. All right, last one, and you better be familiar with this little equation too. If I've got x squared plus y squared equals 9, that's the equation of a circle. I'm going to subtract x squared from both sides, and I'm going to take a square root. So a positive root is the top part of the circle, the negative root is the bottom of the circle. Okay, so it says find the derivative to the left at x equals 3. It means that I have a radius of 3. So from the left at x equals 3, and then again from the right at x equals 3. Okay, so can I do this? So if I'm coming at it from the right, can I take that derivative? Absolutely not, because there's nothing over here. Okay, so this does not exist. And then what's the derivative from the left at x equals 3? That one, hang on, I'm getting thrown off because you shouldn't know how to do that yet. Anyway, is it differentiable at x equals 3? No, because there's a pointy part there. All right, so that's it.